Hello everyone, I'm Math Angel Vade. So this is my first video and we're going to answer some of the questions in calculus exercise derivatives. So this is just the part one. So there are more parts to be uploaded sooner. And this is actually the remastered version, all right, because I already uploaded this type of video in the previous month or like in the previous weeks. However, due to lags because of my own internet. So I'm gonna re-upload it again. All right. So without further ado, guys, why not let's begin answering these questions. Okay. So in the first question or first problem rather, we are asked to find the derivative of the given problem or the given expression. So before we begin, let me introduce you some of the differentiation rules to be used here. All right. So we are asked to get the derivative of, first, let's just say we have a variable, we have x, and then let n be the exponent. All right. So if ever you see an exponent, right, what we're going to do here is just you're going to bring down the exponent, copy the variable, and then the exponent above that is given, subtract it by 1. That's it. But what if that variable has a constant? All right, constant. Let's see be the constant. All right, could be a negative, positive number, real or irrational. All right, I mean rational or irrational. Okay, so if this is the case, all right, we have this what you call constant rule of differentiation, wherein whenever we derive something, it could be any term, it could be in any expression, but if we have a constant here, we should never touch them. All right. So we copy the constant. All right. Then we're going to do the same process as what we did in the first rule here. So excuse me, bring down the exponent, copy the variable, and then subtract the exponent above by 1. All right. But I'll give you something. All right. So what if I'm asked to find the derivative of, let's just say, a constant, and then I have an x only, and how about the derivative of c? Basically just a constant term. All right. So let's start with this one. If we're asked to find the derivative of a term where you have your coefficient and x, don't get me wrong, this x has an exponent of 1. All right, because any term or number basically is always raised to 1. Okay, if it's existed like this one. Like for example, I have 9. Okay, could be equal to 9 raised to 1. X is just the same as x raised to 1, right? Which is just similar as the rule here. All right. So yes, it is just once again similar as the first rule that I already introduced to you, the power rule. All right, wherein you have a variable and exponent. But in this case, wherein the exponent of your variable x is equals to 1, well, just remove, oh, sorry. Well, just that's just like, remove the x and then copy the coefficient. That's it. That's what you're going to do. Then last but not the least, what if the constant term is only given? All right, could be in any type of constants. All right, so the derivative of that is 0. Okay, now let's apply it here in this first problem. So in this first problem, we have x cubed, right? X cubed. So in this case, again, in this first term, we are applying power rule. All right. If you guys don't know, if I hadn't mentioned it earlier, the first rule that I already introduced to you, the x raised to n, that is what you call the power rule. So in this first term, this is an application of power rule. So what to do if we have this type of term? So just bring down the exponent, copy the variable, then subtract its exponent above by 1. That's it. Next, here. The second term, we have 2x squared. Well, that's the same thing, all right? We're going to use power rule here. Again, because we have a variable that its exponent is 2, all right? So, before that also, we have 2 here. So that means that it's your coefficient. So what do we do here? We, once again, copy the constant, right? Then we can now find the derivative of that variable and the exponent, which is your 2. So we bring down 2, copy the variable, and then subtract the exponent by 1. That's it. And now last but not the least is the 50. Since 50 is just a constant term because it has no variable given, so again, the derivative of a constant term is 0. So that's already what? Nothing anymore. So let's further simplify. So we have 3x, 3 minus 2 squared plus, right? We have here 2 times 2, so we have 4, and then 2 minus 1 is just 1, right? Therefore, we have your answer, right? We have 3x squared plus 4x. That's it. All right. Don't worry. In the next question, I'm gonna, write these letters or all of the terms bigger. But yeah, that is your answer. Next problem. All right. How about this one? All right. We have a given problem, and we have 4 square root of x plus 1 over x plus 5x raised to 4. Okay. So before we do anything, let me again give some recall. All right. So let me get this square root of x. All right. So by the laws of exponents, or if you will recall in your algebra lessons, okay, if you ever see this one, it's just the same as x raised to 1/2. All right, 1/2. Oh, this is 2. All right. Sorry, because I use highlighter as my writing tool, right, for recalling concepts. So yeah, anyways, that's how you do it. So if ever you have a cube root of x, that means this is x raised to 1 over 3. All right. So as you can see here, if you have a root, okay, and here let this be n, it could be cube root, fourth root, fifth root, and then you have a given variable. So this is always what? X raised to 1 over n. Next is, how about if like I have 1 over x, all right? So this is just basically a, what do you call this one, a reciprocal, all right? Because if ever we see this one, this is just the same as x raised to negative 1, all right? So basically, in other words, if ever you see this type of term and then you have x below, so you just need to get the exponent of it, okay, bring it up, but then you have to make it negative, all right? So for example, if I have 1 over x squared, and then now since you have 2 as your exponent, therefore, yes, copy the x, and then bring them up, and then this will become negative 2. What I mean by bring it up, meaning like this x will become a whole term, not basically from the denominator, so it will become a whole term, and then copy the exponent but make it negative. Right? So that's it. Let's go. So in this case, I can rewrite this one as the derivative of 4x raised to 1/2 plus, oops, hold on, x raised to negative 1 plus 5 times x raised to 4. So as you can see, all of the given terms here, all right, yes, it has a coefficient 4, 5. This one is obviously the coefficient here is 1. But as you can see, they have their own exponents, all right? So therefore, what rule of differentiation we're going to use here is power rule, all right? So again, what do we do? So since we have a constant here, okay, coefficient 4, and then if you recall in the last question that if ever we see a coefficient, we just copy them, right? So we copy 4, then now we can now differentiate further to this variable. So this is a power rule. So again, what do we do if we have a variable and then we have an exponent? So we bring down the exponent, copy the variable, and subtract the exponent above by 1. That's it. All right, plus this one, in this case, has an exponent, so that's it, guys. All right, it's just the same. Wait, let me rewrite the plus sign. It's triggering. All right, hold on. So there we go. Sorry. So there we go. Plus. So bring down the exponent. I will use parentheses here because it is negative. All right. Then copy the variable. Then the exponent above, which is your negative one, subtract it by 1. And lastly, for this one, for 5x raised to 4, I think this one's the simplest one. All right. So we copy the coefficient itself. All right. Then bring down the exponent, copy the variable, and subtract the exponent above by 1. So let's further simplify. So 4 times 1/2 is just the same as 4 divided by 2. So this is equals to 2. Okay. X, then 1/2 minus 1 is just negative 1/2. There you go. Wait, this is small. That's it. All right, good. And now here, this would be negative 1x or negative x. There we go. And then the exponent above, negative 1 minus 1 is negative 2. Plus, there we go, 5 times 4, 20. And then copy the variable and subtract the exponents above, all right, by 1. So it would be like 4 minus 1, so we have 3. That's it. But if you want to make it in a different form of your answer, so this is just the same as 2 times 1 over x. Oops, hold on. There's a better way for me to write this one. Right? 1 over x raised to 1/2, right? Minus 1 over x squared plus 20x cubed. That's it. All right? And why did I do that again? Why did I make it into, in a reciprocal form? Is because if ever we see a negative, again, negative exponent, we make it into a fraction wherein this one will go to the denominator. All right, just like this one, we have negative 2, so this would be like 1 over x squared. All right, so that's it. Okay, and again, whenever we have an exponent, which is, let's just say 1 over 2, so this means that this is a square root. So I will further simplify this one as square root of x minus 1 over x squared plus 20x cubed. There we go. All right, this is the final answer. Next, in this case, all right, this is a squared binomial. All right, you know what I mean by squared binomial, because binomial has 2 terms given, which is the 2x and then your constant term, negative 1. So obviously, this one you may seem like, I think it's better to expand than find the derivative of each. Yes, so that will be the first method that I'm going to teach you. Basically, just expand the whole, then derive each. All right? Or there's this one rule that I can teach you, which is what we call as the chain rule. All right? So, okay, I got it. So in this case, how do we expand a square binomial? Obviously, what we're going to do here is just fold method. So for example, if I have a given of, let's just say x plus y squared, right? So usually what we do is we separate them into 2. That's it. So what we're going to do here is what? Yeah, fold method. you multiply the first terms, the outer terms, then the inner terms, then the last terms. All right. But there's like a technique for that. Like you don't need to. All right. There's like a step or technique. All right. So in this case, all right, square root of x plus y, or square root of the binomial x plus y. So here's the technique here. First, square the first term. When we say square the first term, make sure that this first term will be raised to 2. So your first term here is x, right? So the first step is, again, square the first term. So this is x squared, all right, plus the second step is 2 times the first term and the second term, all right? Basically, 2 times all the terms. So this is 2 times the first term and times the second term or the last term, plus now square the last term or the second term. So here, this is your second or last term, you can say it. So square it up. So this would be y squared. Therefore, what we have here, this is x squared plus 2xy plus y squared. That's it. All right. So we can apply that here. Okay. So the derivative of, don't forget this one, guys. If you're not differentiating, but you guys expand or simplify something inside that expression, don't forget to put the derivative notation. All right. So let's go. So again, since we have a square of binomial, first we square the first term. So meaning we're going to square 2x. Square the first term plus the second step, 2 times the first term and the second term. So that means 2 times the first term and the second term, -1. Don't forget, right? If it has a -1, that means it is -1. Then last but not the least, square the last term. That's it. Now we can simplify this one. Although that's it. So the derivative of this is 4x squared. All right. 2 times 2x is 4x times -1. So this will be -4x and plus 1. Because the square root of a negative is positive. I'm sorry. There we go. So now let's further, let's further differentiate. All right. So the first term given here is 4x squared. So what we're going to apply here is the what? The power rule. Because overall you have a variable and then you have exponents, okay, which is not equal to 1 and 0. So obviously what we're going to do here is what? Again, copy the constant, then bring down the exponent, copy the variable, and subtract the exponent by 1. That's it. Right, next for second term. So if you recall again, like if you have the derivative of a constant or let's just say coefficient with x or a variable, okay, wherein this variable is just, raised to 1 because anything that raised to 1 is just a whole term, just like -4x. So just remove the x. So this is -4x. Or I'm sorry, -4. That's it. Then last but not the least is your constant here. So again, if you're going to derive a constant, this is a what? 0. So plus 0. So now let's simplify them. So 4 times 2 is 8. And then subtract the exponents above. So 2 minus 1, we have 1. Leave it be. And then now we have -4. This could be your final answer, or you can simplify even further. By means of simplifying means I can factor this out. All right. So as you can see, 8 and -4, they have something in common. And both of them are both divisible by 2 and 4, right? But since 4 here is the GCF, or the greatest common factor here, all right? So therefore, I can bring out 4 outside of that binomial. So this would be like 4 times 2x minus 1. Because overall, 8x divided by 4 is 2x, and negative 4 divided by 4 is negative 1. So that's the first method here. All right, so that's a good thing, the first method. But there's also something that I would like also to share to you guys. Hold on, let me put the borderline here. All right, that's it. There's also another technique. All right, so this technique I'm going to teach you is what you call the chain rule. So chain rule, basically to sum it up, you're going to derive the outer part of it, then derive the inner part of it. All right. So for example, all right, for example, okay, usually chain rule are used if you have a composite of functions. So for example, you have f, hold on, f of g, and then times x, which is this just the same as f of g of x. So this is a composite function, if you'd recall. All right. So what if we're asked to find the derivative of this one? All right. What if we're asked to find the derivative of that one? Okay. So let me think of two examples here. So for example, I have my f of x be, let's just say, x cubed. And then I'll have g of x be my 2x plus 1. So if I'm asked to find, f of g of x, all right, this means that I'm going to substitute the given of g of x inside of this function. So this is what? 2x plus 1 raised to 3, or a cube of 2x plus 1. That's it. Now, how do we find the derivative of this one? All right. So this is where we apply chain rule. Not only to those who have cube of binomial, square of binomial and such. No, not only that. All right. But also in different functions such as, sine, cosine, the e raised to x. We're going to use chain rule. All right. If ever there's like another function given inside, right? Like for example, sine x is just, yeah, normal function. But what if we have sine of cosine x? All right. So this is another function inside of a given function. Okay. So the formula, all right, for the chain rule, all right, hold on, let me erase this one. Hold on. Oops, hold on. Okay. So the formula for the derivative of a composite function is just what is, okay, f prime of g of x, all right, times g prime of x. So whenever you saw this type of notation, this prime like this, it's just the same as the derivative of it. Like for example, right, we're asked to find the derivative of f of x, right? It's just the same as f prime, right? F prime. That's it. This is like the simplest way to write it down. All right. So that's it, basically. All right. In other words, okay, to sum it up, derive the outer, then derive the inner part and combine them both. That is the sole purpose of chain rule. All right. Since I don't know if you guys could memorize this one, but I will let g of x be u. So this would be like f prime of u times y du, or in other words, the derivative of u. So that's it, guys. Remember this formula. I use u instead of g of x so that it would be much more simpler or more convenient. Okay, sorry for the wrong grammar. Okay, so let's give this a try. All right. So that u, all right, u or g of x, that is actually inside of the given function. All right. Hold on. Let me erase this one. Okay. Don't worry. I still remember the formula of it. So, all right. Let u be the 2x minus 1, or the function or term or expression given inside of it. All right. Then the derivative of u or du. So let's take it slowly. So the first term is we have 2x. Again, if you recall that if you have a coefficient, okay, and then have a parabol in which its exponent is raised to 1, just remove the what? Remove the parabol. All right. Copy the coefficient itself. Then now the derivative of a constant is just 0. Therefore, you have 2. Okay, that's it. So the formula, again, to get the derivative, wait, before we begin, right? So since u is equals to 2x minus 1, so you have u squared, right? U squared. All right. So now what we're going to do here is we're going to what? Find the derivative of it. All right. So by getting the derivative of it, remember the formula of f of u times du. Okay. So now let's derive u squared. Okay, since this is just a variable, so just bring down the exponent, copy the variable, and then subtract the exponent by 1 times your du, which is your what? 2. So you have 2. So with further simplification, you have 2 times u times 2. So therefore you have 4u. Oops, this is wrong. 4u only. There we go, 4u. And since u is equal to 2x minus 1, so we can just, do this. 4 times 2x minus 1. And that's it. You guys have the same answer as well. All right. How about this one? All right. So we have a given of a binomial times a trinomial. Remember when we say trinomial, this means that we have 3 terms given. So we have 1, 2, and 3. Me? Okay. So there are two things or two methods I can do here. Okay, so first one is what we're going to do is expansion. How do we expand this one? Excuse me. By further expanding this one, what we're going to do here is just basically distribution. All right, so let me rewrite this one as 4x minus 1 times x squared plus 2x minus 3. All right, so now let's basically distribute each terms to the right. So first let's start with 4x. Now let's distribute. Let me use different color. I think it would be far better so that it would be much more convenient and less confusion. So distribute the first term to this one. All right, so 4 times x squared, this is 4x cubed. All right, times 4x times 2x, this would be like 8x squared, times 4x times negative 3, this is like negative 12x. All right, next is we're going to focus to the second term, which is your negative 1. So not subtract, sorry, multiply this one again to the first term of the trinomial. So negative 1 times negative x squared, so we're going to put here as negative x squared times negative 1 times positive 2x. So this is what? Negative 2x. And then last but not the least, subtract the last part. Negative 1 times negative 3. This is positive 3. Now let's further combine them. So by combining them, we have 4x cubed, right? Plus 7x squared minus 14x plus 3. That's it, guys. All right. So Now let's go to find the derivative of it. So since we expand them, right, we have this what we call as the 4x cubed plus 7x squared minus 14x plus 3. There we go. Now, okay, so since we have terms that has again exponents, okay, variable, and then a constant term, so this is basically the combination of all the rules that we use, all right, or the rules that I introduced in the first question. So let's start with this one. So since we have 4x raised to cube, so basically copy the coefficient times, okay, bring down the 3, copy the variable, and subtract the exponent above by 1, plus, same thing here, copy the coefficient, then times, bring down the exponent, copy the variable, and subtract it by the exponent above by 1. And here, since we have negative 14x, so it's just a variable here, so I can just remove it and copy the coefficient itself, which is negative 14. And plus, we have this 3, which is your constant term. This is 0. So let's further simplify this one. This is 12x squared plus 14x minus 14. Okay. Or you can further simplify this one. All right. Since you have 12, 14, and negative 14, all right, three of them have something in common, which is their common factor, okay? Because three of them are all divisible by 2. So basically, their GCF is 2. So I can bring out 2 outside, so I will have what? 2 times 6x squared plus 7x minus 7. That's it. So that's the first technique here. The second technique that I would like you to learn is that, okay, is product rule. All right. So product rule exists if like we have two functions or two expressions or term combined together. Just like this one, a binomial and a trinomial combined together. So in this case, we're going to use product rule. Okay, so I'll give you some illustration, right? So let's just say you have f of x times g of x. Okay, obviously, the result would be like, combination of two, just simply f of x, g of x, right? But what if I told you I want to find the what? The derivative of f of x, g of x. So obviously, if you want to find the derivative of it, so this is it, all right? Basically, f of x times g prime of x, basically the derivative of g of x plus g of x times f prime of x. That's it, right? F prime of x. All right, again, okay, this f prime of x is just the same as the derivative of your f of x. Sorry, the derivative of your f of x. Okay, that's it. So I think it would be better if we use letters, all right, instead of using function notations. So f of x and g of x, all right, I can label f of x as u and g of x as v. So this is just the same as u times the derivative of g, or basically g prime of x. So I'll just use dv. D stands for derivative, all right, and stands for, yeah, your v basically. So u dv plus your g of x v times the derivative of your f of x or f prime of x is du. So that is the simplified what formula for the product rule. U dv, v du. That's it. All right, I'm just basically, introducing you the formula of the product rule here. All right, let me erase this one. Okay, I'm almost done. Just hold on. Okay, so let's have again your u. So my u here is 4x minus 1. All right, and du means the derivative of u is, okay, let's derive. So if you're going to derive this one, again, just remove the variable, copy the coefficient, which is 4. This one is just a constant term, so this would be 0. Therefore, you have 4. Next is your v. Your v here is x squared plus 2x minus 3. And let's get the derivative of your v. So if ever you see this one again, a variable and an exponent, so bring down the exponent, copy the variable, then subtract the exponent by 1, plus we have 2x. So again, if you ever see this type of term, just like the 4x, remove the variable and copy the coefficient. That's it. Then now you have your constant, which is your negative 3. So if you're going to derive any constant, whether it's positive or negative, real or irrational, this would be 0. So therefore you have 2x plus 2. Now let's now substitute. So again, the formula for that is u times dv plus v times du. Let's start with your u. Your u here is 4x minus 1 times your dv, which is what? 2x plus 2. Okay. Next here is your v. Your v here is x squared plus 2x minus 3. Then times your du, which is your 4. Let's go first to the first term here. So in this case, right, we're going to expand them. So what we're going to use is FOIL method. So multiply the first terms, 4x times 2x, this would be 8x squared, times, okay, the outer terms, 4x times 2, this is what? 8x. Now next here is the inner terms, negative 1 and negative 2, this is negative 2x. And last but not the least are the last terms, negative 1 times 2, this is negative 2. All right? Plus, here on the right term, or basically the second term, just distribute 4 to each of the terms. So we have 4x squared plus 8x minus 12, because 4 times 3 is 4 times negative 3 is negative 12. So let's further substitute. All right, I'm sorry, not substitute, like, combine all the similar terms. Let's start with 8x squared. So 8x squared is just similar as your 4x squared, because both of them have common variable, which is x raised to 2. So let's combine them. So this is 8 plus 4. This is 12x squared. That's it. Next, now we have, 8x, negative 2x, and 8x. Three of them have something in common or similar because of their variables, which is x. So 8x minus 2x is just, okay, 6x, plus 8x, this is 14x. And last but not the least, we're going to combine these two constant terms, because overall they're constant, so there's no variable given, only numbers, so that's the similarity. So negative 2 minus 12 is negative 14. Okay, so with further simplification again, the GCF is 2, so I'll bring down 2, and I have 6x squared plus 7x minus 7. That's it, guys. All right. Next. Here we have a rational expression. So when we say rational expression, basically we have a polynomial on below, above, then the polynomial below. So basically two polynomials given in each side of the fraction. All right. So we have x plus 3 and 2x minus 1. So I'll discuss two techniques here. The first technique I'm going to introduce you is what we call as the quotient rule. All right. So earlier, all right, we know that product rule is u dv plus v du. All right. Basically, f of x times g of x or u times v. So basically, we do product rule. Now, how about if we're going to use quotient rule? Basically, u divided by v or f of x divided by g of x. All right. So the formula for the quotient rule, okay, if you want to know, is, okay, hold on. This is, okay, first v times du minus u times dv over v squared. That's it, guys. Right? That's it again. V times du minus u times dv over v squared. So this is obvious actually. So the u here is your numerator. So what is your u, which is x plus 3? Now, let's get the derivative of your u. So again, if ever you see the x, copy the coefficient plus the derivative of a constant, 0. So this is your du, 1. Next is your v. Your v here is 2x minus 1. Basically, v is always the denominator. Next here is the derivative of v. So again, just copy the, okay, copy the coefficient, which is your 2. Then the derivative of a constant is just 0. So this is just 2. So again, the formula for that is v du minus u times dv over v squared. So let's go for the v. Your v here is what? 2x minus 1 times du, which is 1, minus your u here, which is x plus 3, and then your dv, which is 2. Now we have v squared. So that means you're going to square your 2x minus 1. That's it. So let's multiply them. So this would be 2x minus 1 minus, for this one, right, we have 2. So let's distribute 2 on these terms. So we have 2x plus 6. That's it. And we have 2x minus 1 squared. All right, I'm gonna write here since I have no space already. And then now let's further, distribute this negative sign to the right, because ever since that if ever there's like a minus sign, the next to it is a binomial or any term. So that means we're going to distribute this sign to each of the terms. So 2x minus 1 minus 2x minus 6 all over we have 2x minus 1 squared. So therefore, your final answer here is already obvious, all right? You have 2x and negative 2x. Since both of them are similar in terms of coefficients and variables, so this would cancel out. And now I'm going to combine these two constant terms, which is negative 7. So I have negative 7 over 2x minus 1 squared. That's it, right? That's it. So this is second technique that I can basically teach you. All right, hold on, and that's it. We can still use product rule here. Yeah, that's a second technique, product rule. We can do that. Okay, we can. All right. So how do we do product rule? Okay. Recall again that if you have this one. So right, usually we're going to copy the x and then the exponent, but negative. All right, that's it. So it also applies to, like, to let's just say a rational function. Wherein, like, for example, you have a polynomial below, let's just say x minus 1 raised to 3. So that this means that this is x minus 1 raised to negative 3. Okay, so we can apply it here. So let me erase this one first. Okay, so this, I can rewrite this one as the derivative of x plus 3, right, times 2x minus 1 raised to negative 1. All right, so your u here, that I'm just gonna write my u on the top right. I think it would be far better so that I can write all the solutions. So my u here is x plus 3. So the derivative of my, again, u or du. So again, this is 1, all right, plus 0. So this is just 1. Next is my v. My v here is 2x minus 1 raised to negative 1. So how do we expand this one? All right, because overall, whenever we see an exponent raised to something which is not equal to 1 and 0, all right, we expand them, we simplify them, then we derive each of the terms. However, this one is already a different scenario. All right, this is negative 1. So how do we simplify it? How do we expand our one? We're going to use chain rule, right? Chain rule. So again, what's the formula of chain rule? So chain rule once again is basically derive the outer, then derive the inner. But let's take it slow. Let's take it slow for a moment. All right. So the derivative, the formula for that is f of u times du. But since we have u, we're going to use different letter. So what I will use here is z. All right, z. Okay, it's up to you guys if you want to use anything. But for me, I will use z. F prime of z times dz. Or in other words, this is the derivative of, f of z. All right, times dz. So this is just similar as earlier, the question earlier, which is where's that? This one. All right, this one here. Okay, so let's go. In this case, I will let z. I'll just where should I put it? I think it's better if I put it. I will let z be 2x minus 1 and dz. Okay, so if you're going to get the derivative of it, so this one would be 2 and this one, a constant, would be 0. So I will have 2 and that's it. All right. So since z is equals to 2x minus 1, this is the same as what? Z raised to negative 1. All right. Now let's use this formula. Hold on. Wait, let me erase this one. Now let's use the formula of f prime of z times dz. Okay. So so this is dv. All right. So f prime of z. All right. Basically the derivative of what? Z raised to negative 1. So again, z raised to negative 1, just copy the exponent, okay, which is negative 1, times your variable, then the exponent above, subtracted by 1, then times your dz, which is your 2. So to simplify further, we have negative 2 times z raised to negative 2. This is z, by the way. This is z, right? So now we're going to substitute z with 2x minus 1. So we have negative 2 times your z, which is 2x minus 1 raised to negative 2. That's it. Okay, so now let's further substitute. So I can use product rule. So this is UDV plus, excuse me, VDU. My U here is x plus 3, and my dv, which is negative 2. Wait, let me use different bracket here. There we go. Negative 2 times 2x minus 1 raised to negative 2 plus my v, which is, all right, which is 2x minus 1 raised to negative 1 times my du, which is 1. So let's multiply. This negative 2, all right, I can just basically combine negative 2 and the binomial x plus 3 by not distributing, but just combine them, which means I can do it like this one. I can do like negative 2 times x plus 3, right? Then times 2x minus 1 raised to negative 2 plus colon, we have 2x minus 1 raised to negative 1. Okay, I can further simplify this one. I can, all right? As you can see, this first term and second term have something in common, which is their 2x minus 1. So that's their common factor. So if you're asking me what's the greatest common factor, so that I can factor them out, their greatest common factor is 2x minus 1, all right, raised to negative 1. Okay, so due to that, I can factor it out. So I'll factor out 2x minus 1 raised to negative 1, all right, times I have negative 2 times x plus 3, all right, times 2x minus 1 raised to negative 1 plus 1. There we go. All right, now what we're going to do here is combining this two. All right, basically distribution. So I have 2x minus 1 is to negative 1, all right, times negative x, sorry, negative 2x minus 6, right, times we have 2x, right, I'm correct here, yeah, 2x minus 1 raised to negative 1 plus 1. Okay, and since this is already in reciprocated form, when I say reciprocated form, right, we have, for example, raised to negative 2. I can rewrite this one as 1 over x raised to 2, right? So therefore, I can rewrite this one as 1 over 2x minus 1, okay, times, this is, I'll combine this one, I'll have negative 2x minus 6, okay, over 2x minus 1, let me put the fraction here, bracket, plus 1, okay? So I'm going to make this one, this two, I mean, sorry, this whole bracket as a whole fraction. So 2x minus 1 times 1 is just what? 2x minus 1, all right, times negative, wait, sorry. 2x minus 1 times 1, 2x minus 1, then add it with negative 2x minus 6. So let me rewrite this again so that you guys may get it, all right? So 2x minus 1 times 1 is just 2x minus 1. Now plus negative 2x minus 6. So this is what? Plus, okay, 2x minus 1. Okay, all over, copy the denominator, 2x minus 1. That's it. So this one, I'll combine the similar terms. Negative 2x and positive 2x cancel out. And then the constants -6 and -1, I'll combine them. So what I'll have is 1 over 2x minus 1 times -7 all over uh, 2x minus 1. Therefore, my answer here is -7 over 2x minus 1. That's it, which is just the same. Oops, sorry, I forgot. Squared. Again, if you still don't get what I mean, right, I have -2x minus 6 over 2x minus 1. And then I added with 1, right? So if you want to make them as a whole fraction, you simply multiply them and add it here. So multiply this one, 2x plus 1. So it's just the same, 2x minus 1. Okay, 2x minus 1 times 1 is just 2x minus 1. Then now add it with 2x minus 1 here. All right, so therefore, this is what? -2x minus 6 added with 2x minus 1 all over the fraction 2x minus 1. All right, basically again, okay, to make them as a whole fraction, multiply the denominator here, and then what you already multiply here, add it to your numerator. That's it. Next. Okay, in this case, this is gonna be tough because we have again a lot of rules I can use here. Okay, like I can use product rule or quotient rule. But right now, I'm not going to discuss like product rule anymore because overall, that is the longest solution. So if you want to make it as quick as possible, use quotient rule. But before that, okay, I can factor this out, right? I can factor this out, right? This whole rational expression, I can factor this out, right? So this one, this x squared minus 2x minus 3, let me rewrite it here. X squared minus 2x minus 3, all right? I can factor this. So how do we factor out, right? So there's a technique. Look at your constant term, which is your -3. So look at that -3, all right? What I'm going to do here is that I'm going to think a set of factors, right? So at least two sets of factors that will result to -3. So I have 1 times -3 because 1 times -3 is -3, and the other -1 times 3 because -1 times 3 is still -3. All right. So here's the thing. Now I have two set of factors. Now I'm going to add them both. All right. And once I add them, it should be the sum of my middle coefficient of my middle term. Meaning, if I'm going to add them both, make sure that the result is the coefficient of the middle term. Or in other words, if I'm going to add them, this would be -2. So 1 plus -3. So this is what? This is -2. And then the other, -1 plus 3, this is what? +2. And since here, 1 plus -3 is equals to -2, and -2 is a coefficient of the middle term, therefore we're going to use 1 and -3. So therefore, this is what? This is x plus 1 times x minus 3. So I can rewrite this one as the derivative of, okay, x plus 1 times x minus 3 over x minus 3. Oops, there you go. Wait, let me rewrite this one. There you go. Now after that, since I have x minus 3 above the numerator, which I mean basically the numerator, and I have x minus 3 below the numerator, which is your denominator, I can cancel this out. And what I have is just the derivative of, oops, the derivative of x plus 1. So now this is like the simplified expression. So what I'm going to do here is derive the terms, each of them. So let's derive x. Again, if you ever see this term, remove the x, copy the coefficient, which is 1, plus the derivative of a constant term, this is 0. Therefore, your answer is 1. Okay, that's it. Next, we have this one. This one is long and intimidating because of course, look at the coefficients and the given, given exponents. We have -5, right? It would be understandable if it's -2, but we have -5. And look at the given coefficients for the second term and the third term. It's big, right? But to be honest, guys, it is still easy because overall, those terms are just basically basic power rule. And of course, we have a constant rule, all right? Or basically, how would you derive a constant? I'll explain later, all right, about that. But for now, let's focus on this one. So since I have x plus 100, x raised to -5 plus 50, x raised to -2 plus square root of 2. Now, I think we already know what to do here. First, let's start with your x. So your x here. So what is again the derivative for this one? All right. Again, if it's just an x or any coefficient, like could be negative or positive, okay, x sub 0, and then we have x here. So just basically remove the x. Just copy the coefficient. So the coefficient here is 1. So that's it, 1. All right. Plus, okay, this one we're going to use power rule. So in this case, I'll copy the coefficient 100 times, bring down the exponent, -5, all right? Then copy the variable, then subtract the exponent above by 1, plus we have 50, all right? Copy the 50, it would be your coefficient, times, bring down the exponent, which is -2, and then copy the variable, and then subtract the given exponent by -1 plus square root of 2. So square root of 2, what would be the derivative of that? Obviously, the derivative of square root of 2 is just 0. Why? Square root of 2 is just a constant number. Unless if there's a given x there, x or any term, that would be understandable for me to derive in a different rules. All right, but still, look at this one. All right, this is square root of 2. All right, still there's no x nor other terms used here except square root of 2. Square root of 2 is just a constant term, right? It's just basically a number, all right? Specifically, an irrational number, but it is still a constant. Therefore, the derivative of square root of 2 over 2 is 0. All right, so by simplifying them, I have 1 plus 100 times -5. This is minus 500 x raised to -6, right? Then this one, -2 times 50 is -100 x raised to -3. And therefore, this is your final answer. See, it's easy, all right? If you knew the rules, you already mastered them, this is easy, all right? Next, okay, this one is a bit of a challenge because we have a long expression above in the numerator. This is like a quintic function because this is x raised to 5, then 4, then 10, x cubed plus 2x squared plus 5x plus 50. And then the denominator, we have x. So obviously, what we're going to use here is either product rule or we're going to use what? Quotient rule. However, in this case, I think I'm not going to use those product rule nor quotient rule. Do you know why? Because this one, I can simplify this one further. All right. So let me say that I have an example, right? Let me use different tool here. There you go. Let's just say I have y minus 2 plus, let's just say 2y, all right? Then my denominator is, let's just say x. So this is just the same as y over x minus 2 over x plus 2y over x. Right? Let me give you another example. What if I have, let's just say, again, y squared, right, plus 4y. And then I have over y. So this is just the same as y squared over y plus 4y over y. So this is an example of similar fractions, right? If you ever see an expression and it's been separated by the operations, whether it's positive or negative, except if it's multiplication and division, because that will be a different scenario. So this is also equivalent to this type of expression, right? Basically been separated, right? Been separated, all right? But then their denominator is their denominator from the left side, which is still x. That's also the same thing here as well, and 2 here, all right? So can we do that in that problem? The answer is yes, we can do that, right? Let me erase all the writings. So this one, I can rewrite this as the derivative of, right, x fifth raised to x plus x raised to 4 over x plus 10x cubed over x plus 2x squared over x plus 5x, there you go, over x plus 50 over x. Now let's simplify each of these terms, all right, so that it's easy for us to derive. So as you can see, we have x raised to 5 over 5. Sorry, over x. So you see, they have the same base. It's just that they have different exponent. First, on the above, you have 5, and in here, it's obviously that the exponent given here is 1. Remember, a whole number or whole term is always raised to 1. All right, just like this one, I have y is just the same as y raised to 1. Am I right? Any whole term or numbers or what is always raised to 1 unless its exponent is given, which is not equal to 1. So it would be a different scenario already. So what do we do if we have the same base? Okay, I'll use this as an example. The same base on both sides of the fraction. However, they have different set of fraction. So according to the rules or laws of exponent, copy the base and then subtract what? The exponents. 5 minus 1. Therefore, this is what? X raised to 4. All right, that's it. Or in other words, just simply cancel out. So here, this is already what? X raised to 4. This one, 4, and then you have what? The exponent of 1. Same thing goes on to the other sides. All right. So 4 minus 1, this is what? Plus x cubed. Plus here we have x cubed, and then we have, all right, a exponent from the x in the denominator as 1. So this is what? 10x squared, right? 10x squared. Plus we have 2x squared over x. So just basically, again, subtract 2, the exponent, all right, by 1, which is the exponent above. I mean, sorry, exponent below, which is, yeah, the denominator. So this is what? 2x. And here for this one, 5x over x, so they're just the same. So yeah, if you're going to subtract them, 1 minus 1 will be 0. Or if you're going to cancel them both, you'll have 5. And that's it. All right. So basically what I just did from the first part, I still, I know, like basically what I did from the first part here, I also did from other terms, like in these terms. How about this one, 50 over x? So if you have 50 over x, again, if you recall, all right, like 1 over x, this is just the same as x raised to negative 1. Therefore, this is what? Copy the constant or coefficient 50, then this is x raised to negative 1. So this is what we say 50 times x raised to negative 1. Now we can derive all of the terms. So let's start with this one. So 4, again, I'm bringing down the exponent, copy the variable, and subtract each exponent by 1, and same thing goes on to the next terms. Bring down the exponent, copy the variable, subtract each exponent by 1. Now wait, this is wrong. There we go. This is 3 minus 1 plus, from here, again, copy the coefficient, times, bring down the exponent, which is here 2, then x, then subtract 2 by 1, that's it. This one here, we have 2x, so if we have this type of term, so just remove the variable and just copy the coefficient. Then here, this is the same from the other terms, so just copy the coefficient, then bring down the exponent, copy the variable, and then now subtract its exponent by 1. Therefore, your answer here is 4x cubed plus, plus 3x squared plus 20x plus 2 plus, oh sorry, this is not plus anymore because it's already negative. Because 50 times negative 1 is negative 50. Therefore, we have minus 50 raised to 50x raised to negative 2. Or if you want me to simplify further, this is what? 4x cubed, 4x cubed plus 3x squared plus 20x plus 2 minus 50 over x squared. That's it, right? That's it. So either way, these two, they're both correct. So that is your final answer. All right, so this is the last part. So this last part, obviously, this is going to be challenging because overall we have square roots plus 2x plus 1 and x squared minus 4x plus 3 and so on and so forth. So obviously, if you want me to rewrite this one, all right, if you want me to rewrite this one, this is like, x squared plus 2x plus 1 raised to 1 half plus x squared minus 4x plus 3 raised to 1 half. That's it. Okay, so you see this one. How do we expand this one, right? So what we're going to use here is chain rule. Because again, we can expand this one, so therefore we cannot just simply find the derivative of it by not using the chain rule. All right. So again, chain rules is basically derive the outer, then derive the inner part. But right now, what I'm going to explain to you is, basically the, what do you call this one? The slowest way as possible. But don't worry, in the next parts, I'm going to basically, let's just say, let you all learn on how would you do it directly or straightforward, right? So before that, let me simplify this part. Let me simplify this part, all right? So x squared plus 2x plus 1. If you guys don't know, this is x plus 1 squared, all right? This is x plus 1 squared, if you guys don't know. How do you know it, guys? First and foremost, how do you guys know it, right? Like, how? Okay, so I know this one because first and foremost, all right, first, as you can see, this 2x, try to imagine this one, all right? Look at the constant. The squared of constant 1 is still 1, right? Then what if you add 2, 1? So 1 plus 1 is 2. So therefore, this is x plus 1. All right, next, I'll give you an example. X squared plus 10x plus 25. So 25, what is the square root of 25? It's 5, right? Because the perfect square of 5 is 25. Then next, let's focus on 10. Let's add two 5s. 5 plus 5, 10, right? So therefore, this is what? x plus 5 squared. All right. And then also, last but not the least, let's try this one. X squared minus 6x plus 9. So what is the square root of 9? So this is what? 3, right? Okay. How about this one? Negative 6. If we add two threes, I have positive 6, right? But what if I add two negative 3? So I have minus 3, like negative 3 minus 3. So I have negative 6. So meaning this is 3. So therefore I have x minus 3. You guys get the pattern here. This one, you square this one, or the square root is 1. If you're going to add this one, this is 1 plus 1. So all of them are all 1. Here, 5, the square root of it is 5. And the square root of 5 is 25. And if you're going to add 5 and 5 here, it's going to be 10. So all of them are all what? 5. And same thing here, 9, right? This is 9, sorry. So the square root of 9 is 3. And if you're going to square it, it is still 9, right? And if you're going to add 3 and 3, that would be positive 6. However, if we're going to add negative 3 and negative 3 together, it is still 3, despite the signs. Alright, despite the signs, whether it's positive or negative to be used, but still the given here is 3, right? Therefore, it is minus 3, alright? Instead of positive 3, we're going to use negative 3 since if you're going to add two negative 3, it would result to a negative coefficient in the middle term. All right, how about this one? X squared minus 4x plus 3. How about this one? So if you're going to square root this one, it would be square root of 3. All right, or if you're going to square that, it would be like 3, right? Then how do we get negative 4? All right, how do you get negative 4? All right, how do we get that? So that would be different scenario. We can just simply say, negative square root of 3 minus negative square root of 3, or square root of 3 plus square root of 3. Now, we can't do that, right? We can't. What we can use here is two terms, right? But the terms are not equal to what? The value. Okay, despite the signs, they will not be equal, right? Look at this one. We have 1, 1, all right, 5, 5, negative 3, negative 3, all right? They have the same signs, but we focus on what? The numbers here. But how about this one, negative 4? No, we're going to use two different terms. So therefore, this is not a what? Perfect square trinomial. This is not a perfect square trinomial. All right? All right. So, excuse me. So yeah, that's a technique I learned. All right. Okay. So again, this becomes negative 3 since two negative 3's results to negative 6. And if you would square negative 3, it's still positive 9. So yeah, anyways, let's go. So this means, all right, I can rewrite this one as the derivative of, all right, I think I'm going to use different bracket here. All right, hold on. This is the derivative of, here we have, what equals 1, x plus 1 squared raised to 1/2 plus x squared minus 4x plus 3 raised to 1/2. All right, and that's it. Right, raised to 2. This is raised to 2, guys. Wait, let me rewrite this one. There you go. So if you guys don't know that, there's a rules in the exponent. Right, for example, if I have, this is square root of x squared, which is again is just the same as x squared raised to 1/2. So if ever you have, like for example, right, you have x squared. So if ever you have a given exponent for your x and then you have the square root in an exponential form, so what you're going to do is you're going to multiply these two. So this is what? Copy the base, then what? Multiply the two exponents. So 2 times 1/2. So this is x. So let me give you another example. If I have cube root of x minus 1 raised to 3. So this is what? All right. Basically the same as, okay, this would be like x minus 1 raised to 3 times 1 over 3. All right. So multiply 3 and 1/3. All right. Because that's the rule here. All right. So x minus 1 raised to 3 times 1/3. So you will have x minus 1 as a result. So that's it. All right. So that's it. So in this case, let me erase this all. All right, let me erase this first. Okay, hold on. Wait. All right, I'm done. That's it. So in this case, all right, we're going to multiply the exponent 2 and 1/2. So 2 times 1/2, this is what? Right, 2 times 1/2, this is just simply 1. So therefore, I have x plus 1. That's it. Then plus, yeah, x squared minus 4x plus 3 raised to 1/2. That's it. Now let's derive each of these terms. Let's focus this one because this left part is easy than the right part. All right. So let's derive the x. So again, if you're going to derive the x, just simply what? Again, just remove the x, copy the coefficient, which is 1. Plus, you have 1 here. So this is your constant. So this is just 0. Now let's focus on this one. So again, right, I told you earlier that we need to use quotient, not quotient, chain rule, right? Chain rule. So how do we do chain rule again? Basically, to sum it up, derive the outer, then derive the inner part. But then again, since you may not get what I mean, so let's just take it slowly, right? Say it slowly, all right? So I will let u be x squared minus 4x. Because again, right, I told you derive the outer, then derive the inner. So I will let the inner part be u. And now let's get the derivative of your u. So this one, bring down the exponent, copy the variable, and subtract the exponent by 1. All right. Then next here, since you have 4x, so just remove the x and just get the 4 plus the derivative of constants would be 0. So you have what? 2x minus 4. That's it. All right. That's it. Now, if you want to look like how does it look like, okay, this would be like this one. The derivative of what? U 1/2. All right, U 1/2. Okay, so let's get the derivative of U 1/2, which is this one, right? This one. All right. So again, if you're going to get the derivative, again, bring down the exponent, copy the variable, subtract its exponent by 1. And since you are in the process of differentiating, don't forget to what? Put the u. All right, because again, the formula for the chain rule, all right, chain rule is f prime of u times du. All right, that is the formula for this one. So meaning you need to find the derivative of this one, which is this, and then the du, which is this one, because du represents the derivative inside of your function, which means that the derivative inside of x squared minus 4x, the derivative inside the square root of x squared minus 4x plus 3. All right, so let me edit the arrows. All right, okay, so let's begin. Okay, so in this case, I'll have 1/2 u times negative 1/2 times du. Now let's substitute. Now I have 1/2 times my u, which is my x squared minus 4x plus 3, right, raised to negative 1/2 times du, which is 2x minus 4. All right. So in this case, I will have 2x minus 4 all over. Since this one is a negative, if you recall that if there's a negative exponent, you can just bring them down in the denominator. All right. Like this one, like x raised to negative 2, this is just the same as 1 over x squared. All right, so that's it. So we have 2 times x squared minus 4x plus 3 raised to 1 half. And now these two terms, we have 2x and 4. So you can see both of them have something in common because 2x and negative 4 are both divisible by 2. So that means the GCF of 2x minus 4 is 2. Therefore, I'll bring out 2 outside. So I will have 2 times x minus 2 all over 2. And then I have x squared minus 4x plus 3 raised to 1 half. And since I have 2 on both numerator and denominator, so I'll cancel this out. And what I'll have is x minus 2 all over x squared minus 4x plus 3 raised to 1 half. That's it. So therefore, I'll rewrite it here. I'll rewrite here. Oops, hold on. I will rewrite here. So this would be like plus x minus 2 all over x squared minus 4x plus 3 raised to 1 half. Right? And I can simplify this one further by 1 plus x minus 2 all over square root of x squared minus 4x plus 3. That's it. Right? That is my final answer. Okay. So, yeah, that's it. Before I end this, what I so-called, you know, session or this video session, let me try this one. Like, right, we have square root of x squared minus 4x, right, plus 3, right? Right, I told you that the summary of chain rule is just basically, derive the outer, then derive the inner and multiply them both. But what we did earlier is slow, it's very slow. So can we do it like the one I said, uh, like derive the outer, derive the inner, then yeah, multiply them together. Can we do that? Yes, we can. Let's give this a try. The outer part here is your basically, you know, a basically a trinomial raised to an exponent of 1 half. So again, derive the outer part. The outer part here is what? Your 1 half. All right. It's like square root of a trinomial. So what do we do is we bring down the what? Exponent. Same rule in power rule, okay? Same rule in the power rule. That's it. Then x squared minus 4x plus 3, then raised to 1 half minus 1, right? That's it. Then times, derive the inner part, which is your x squared minus 4x plus 3, all right? So this would be what? 2x minus 4. And that's it. That's it, guys. See, it's simple. Thank you again for listening. And here, this is Math Angel Vade. So I'm here to guide you while you're answering mathematics. See you.